A year before the moon landing, you were at the Owens Valley Radio Observatory, where you were collecting data for your thesis about using the wavelength of hydrogen to measure the spin of galaxies. You were the only human within a 30-mile radius, so you amused yourself by taking pictures of telescopes, of yourself, by reading books. This is eerily similar to the plot of The Shining, by the way. One night at 3 a.m., you were reading this book in one of these crazy spirals. You were reading this book called Intelligent Life in the Universe, written by this Russian cosmologist, Seth Shostak, edited by someone named Carl Sagan. I don't know if that name rings a bell to you. And you had this eureka moment that these same antennas that you are using to measure the spin of galaxies can also be used to search for aliens. This is one of the underlying principles of the SETI project. So let's go there. What is the SETI project? What are you looking for?
Yeah, SETI is just an acronym. In fact, it's a generic acronym. It isn't owned by anybody, but we're called the SETI Institute because we do SETI. But SETI is simply the Search for Extraterrestrial Intelligence. That's an old idea. I mean, people in the 19th century were looking for Martians, and they thought they saw their handiwork on the surface of Mars. So SETI is sort of a modern incarnation of looking for cosmic neighbors, right? And the way we do it is we look for signals, mostly radio signals, not exclusively, but mostly radio signals. And we, just point antennas at nearby star systems, hoping to pick up a transmission that's either deliberately sent into space, in our direction because they suspect there's somebody here, or maybe, they're not deliberately broadcasting in our direction. Maybe they're broadcasting in all directions. But if we can pick up the signal, that, well, at least there's something or someone out there smart enough to build that transmitter. So that's a profound discovery.
This seed, the thought or the seeds of thought were planted in 1959 or 58 when this paper was published titled Searching for Interstellar Communications, where Giuseppe Cocconi and Philip Morrison said the probability of success is difficult to estimate, but if we never search, the chance of success is zero. Was this a radical thought at that point that we need to look for aliens? Was there a stigma associated with trying to search for extraterrestrials?
I don't think it was. I never had the impression that it was something that greatly surprised anybody because, as I mentioned, that had already been tried, right, using very simple telescopes that would fit in your bedroom. I mean, some relatively small telescopes, and people would look at the other planets of the solar system. I mean, in 1900, I think that most of the population of any country, not to mention most of the scientists, assumed that there was a lot of life out there. And many people assumed that there was other life even in our own solar system, right? Mars in particular, but maybe also Venus, some of the moons of Jupiter, whatever. These were all places that could, in principle, host life. And most people believed it was out there to be found. So the big surprise was not searching for life. The big surprise was perhaps that it's been so hard to find.
What kind of telescopes do you use at SETI? What kind of signals do they detect?
Yeah, well, there are various kinds of telescopes, obviously. There are the mirror and lens telescopes that everyone's familiar with. Those have been used also, by the way, to search for ET. It might be a great way for an advanced society to communicate with, its colonies or other societies or whatever. If they want to communicate between the stars, how do you do that? You could try and find a mailbox and, put something in there. Hope it gets to another star system. Probably not going to work. But what could work is to send a signal up there, like a radio transmission or a light beam, both of which travel at the speed of light. So that's the fastest you can communicate anyhow. So, and it's also not terribly hard to build a laser or a radio transmitter. I mean, we do it all the time now. And the aliens, presumably, at least the sophisticated ones, will have knowledge of these sorts of technologies, and they'll be able to find flashing lasers coming from other star systems.
How do you know which frequency to listen at?
You don't know what frequency to look at to listen to if you're doing a radio search. But the first searches were conducted at frequencies that were very close to a natural emission frequency of the hydrogen atoms. Hydrogen atoms, you take a bunch of hydrogen atoms, you put them here on this table, and they will spontaneously, slowly, but they will spontaneously emit a little bit of radio waves, okay, a little radio radiation. And that's just physics. That's sophomore physics, if you will. But we know that, and the aliens will know that, and that gives you a kind of a preferred spot on the radio dial where you might expect transmissions, because everybody will know that frequency, everybody that has sophomore physics.
Why would that definitively prove the existence of extraterrestrial civilization?
You have to look at the characteristics of the signal. The universe makes lots and lots of radio waves, right? I mean, the sun spews out radio noise all the time. Yeah. Jupiter spills. I mean, almost anything that's at least a little bit warm produces a measurable amount of radio radiation. So that's not so surprising. But what a transmitter does that something like the sun doesn't do is produce a radio transmission that's at one spot on the dial, that's at one frequency, whatever it is, right? I mean, think of your local television station. It's broadcasting radio waves into the atmosphere, into the environs, wherever it is, right? But it's at one spot. It's at channel 7 or it's whatever, okay? Nature doesn't do that. It just typically, not always, but typically it produces radio radiation at all frequencies, just like light. Stars are not just one color. They're basically all colors.
Is the frequency of hydrogen, was it 1.42?
That's 1420 megahertz. Is 1420. Yeah. I mean, it's known to like 10 decimal places or something, but in any case, that's roughly what it is, 1420 megahertz.
The water hole.
Well, the water hole is slightly different. The water hole is the region of the spectrum between the hydrogen line frequency and another naturally occurring radio signal, which is called is due to the hydroxyl radical, OH, if you're a chemist. So, that also produces natural radio waves. And between those two is a fairly narrow part of the spectrum that, again, even the aliens will know about, at least the ones you might want to hear from.
42, this number suspiciously keeps coming up. I feel like Douglas Adams was onto something when he said 42 would have some meaning.
Yeah. Well, it's one of 100 two-digit numbers, so maybe it's not so surprising that it means something to somebody.